For my birthday, I got a facelift. I hope you like it. Have fun watching me doing math with my old face.
See what happens. Let's record this for 15 minutes. We are doing properties of logs. And I don't have my mask on, that's kind of fun. So, let me see. Properties of logs. Now, you guys know stuff about logs already. You know that logs are powers, right? Power. Hopefully I can. Power equals log. And then there are two parts of the log, right? There's the base of the log, just like there's the base of an exponential. And then there's a number you evaluate the log of. I saw one teacher call it an argument. So it's kind of fun. But anyway, power equals log. So since logs are powers, they follow like the power rules, right? So if you have 3 to the 4th power times 3 to the 3rd power, of course, when you multiply things with the same bases, you just add the power. So it's 3 to the 7th power. Okay, since powers are logs, now if you have the log of a product, like when you're multiplying here, log of 4 times x, right? We'll just call that a product. We'll say log base 5. You can rewrite that as the sum of two logs. That's the log base 5 of 4 plus log base 5 of x. Okay? And then you can probably guess what you can do when you have a log, any base, I'll say 2, log base 2 of x over 3. It's made it up, I'm just showing an example. When you have the log of a quotient, instead of adding, because when you have a quotient, 2 to the 3rd power divided by 2 to the 5th power, you subtract these powers. It's 2 to the 3 minus 5, which is 2 to the negative 2. Of course, you know that that means it goes to the denominator, right, to make the power positive. Okay? But at any rate, when you're dividing, you subtract the powers, and logs are powers. So when you have the log of a quotient of a division thing, you get log base 2 of x minus log base 2 of 3. You can rewrite the log of a quotient as the log of a difference of two logs, or the difference of two logs. Okay, and that's a thing. Also, there's one more thing. If you've got a log, any base 7 of 5 to the 3rd power. Okay? Since when you have a power of a power, you multiply the powers. When you have a power inside of a power, right? This power on this exponential part can become a coefficient in front. So that would equal 3 times 3 times log base 7 of 5. And I know those are weird rules, but really, you've got 3 rules to remember. Yeah. I think about 3 rules to remember. Okay? But anyway, when you have the log of a product, you can write it as the sum of 2 logs. When you have the log of a quotient, you can rewrite it as the difference of 2 logs. And when you have the log of something to a power, that power can come down and become a coefficient in front of the log. Okay, so let's check out and see what we have here. Oh, and this is just reminding you of the rules, right? When you have 3 to the n divided by 3 to the 2, you can rewrite that as 3 to the n minus 2. right, a power rule, and that equals 3 to the 5th power. Now from here, you should be able to set up an equation to figure out what n's value is. Since the bases are the same, you can set the powers equal, and then solve for n, right, by adding 2 and a 7. Oh, number 2 looks like it's the same problem, right? Just reminding you of power rules. When the bases are the same and you have a difference of 2 numbers, right? If the base is the same, you just subtract the powers. 4 minus n equals x and negative 2. And then from that, you get an equation that you can solve for n with. Since the bases are the same, the powers must be equal. 4 minus 10 equals negative 2. And you can solve that equation. I'm just going to put a little smiley face. Maybe you probably can figure out what the rest of that is. Okay? The same thing here. When you're multiplying two things with the same bases, we can add the powers. 2 plus n next to the 5 halves, or 2 1/2. And then you can write out an equation that you'll be able to solve. And maybe 5 is worth looking at. I'm going to skip 4 and 6. So when you have a power of a power, remember you multiply the power. So the numerator is y to the 2n. The denominator is y to the 3rd. And then it was y to the invisible 1, right? So this one on there. You can rewrite this first fraction as y to the 2n minus 3 equals y to the 1. And then from that, 2n minus 3 equals 1. You have an equation that you can solve. And I'll let you solve that, or you can just solve that in your mind. But anyway, follow the rules of the powers, and you'll be able to set up an equation to solve it. Not part of the lesson, but important to review some old stuff. Here's another old stuff thing. And I'm not going to go over it. It doesn't have too much to do with our lesson. But how can you use the properties of exponents to derive properties of logs? Okay. These next few screens I don't think are completely clear, so I'm going to skip them, but I'll go to this property. When you have any base log to a product, m times n, you can rewrite that as the sum of 2 logs. Same thing with a quotient, m divided by n. You can write that as the difference of 2 logs. You have the log, any base, and inside of the log is a number to a power. Right? You can rewrite that as the coefficient n times log base b of m. Those are the 3 properties you have to memorize and know. Now, we know that you can just take your calculator for any of these log values. We know that. And you can just use log base, right? Math, log base of 2, and get a decimal approximation for this, right? Log base 2 of 3/7, and get the correct answer, the decimal approximation. But that's not what's important here. What you should be practicing, so you're ready for the test, is how to rewrite this in terms of log base 2 of 3 and log base 2 of 7. Like, how would you rewrite this? It's a difference. So we can, I'm sorry, it's a quotient, division. Right? So we can write this as the difference of 2 logs. Why don't you take a moment, pause the video, see if, just take 1 minute, pause it, and see if you can do B and C. And try to get them in terms of log base 2 of 3 and log base 2 of 7. Okay, that's what I want you to do. Okay, we'll just try that. Pause it now. All right, so anyway, hopefully you paused them. I'll go over these answers really quickly. And of course, Mrs. Clovis knows all this. So if you have questions, feel free. She's an awesome teacher. I probably didn't even have to make this video, but you know, weird things happen in case she can't show up. And I've got a plan B, and this is kind of it. Okay, so anyway, this you could, you know, 21, since we know, is 3 times 7. This is log base 2 of 3 times 7, right? And when you have a log of a product, you can rewrite it as the sum of 2 logs. Log base 2 of 3 plus log base 2 of 7. And then, of course, you can use these decimal approximations, add those 2 decimals together, and you'll get the same decimal as you would have gotten as you just used log base 2 of 49, or log base 2 of 21. So 49. I don't know how you can use 3 and 7 to get 49. You can use 7, because 7 times 7 is 49. So log base 2 of 7 squared. And that's the third rule, right? Because we have a power on something inside of a log. This power can go to be a coefficient out front. So we have 2 times log base 2 of 7. And then if we're going to use this, you know, the direction, we have 2 times 2.807. And then whatever number that is, that's the decimal approximation. But of course, you can just plug it in your calculator. This one we say 1.585 plus 2.807, and this one is 1.585 minus 2.807. And just stuff. Okay. These are the same kinds of problems. So pause for a second. See if you can do these on your own. If you have questions, raise your hand and ask. See if you can get these 4 in terms of log base 6 of 5 and log base 6 of 8. Okay, just pause for a second and take the time to do that. Okay, so I'm going to go through these. Let's see. Just want to make sure I have room. Log base 6 of 5 over 8, you can write is the difference of 2 logs. And then you can use those decimals if you need to, right? The second one, 40, remember, is 5 times 8. Log base 6 of 5 times 8. So you can write that log base 6 of 5 plus log base 6 of 8. 64. If you look at there, you know that 64 is, oh, that's not right. 64 is 8 squared. Okay, sorry. So we can rewrite this as log base 6 of 8 to the second power. This power 2 can come out front. Hopefully you guys are getting good at this and thinking through these. And then log base 6 of 8, you can use this 1.161. Right? And 125 is 5 to the third power. That's where you can use that, because 125 is in the cubes list. Log base 6 of 5 to the third power. That coefficient 3 can come out front. 3 times log base 6 of 5. Okay? And I'm going to stop right here because my YouTube, I think I can only have videos of 15 minutes, and I think it's been about that. So I'm going to stop here.